Today, we are pulling back the curtain on modern AI. I mean, we see what it can do, and it seems like straight-up magic sometimes, doesn't it? But what's the actual architecture that lets a model write a whole essay or generate complex code in seconds? Well, in this explainer, we're going to break down that exact blueprint. And we're basing our discussion on Chapter 5 of Zahir Ahmad Mir's fantastic book, AI, Your Smartest Partner in Life and Work.
Assalamu alaikum everyone, and a very warm welcome back to our channel, Digital Future AI School. It's great to have you with us again.
So this is episode 5, and as I mentioned, we're diving into the 5th chapter of the book AI, Your Smartest Partner in Life and Work by Mr. Zahir Ahmad Mir. Before we jump in, if you enjoy what we do here, please do me a quick favor. Kindly subscribe to our channel, give this a like, and share it with your friends. It helps us out a ton. All right, let's get to the big question.
We've all played around with AI models like GPT, right? And you have to admit, it feels like magic. It's incredible. But it's not magic. It's engineering, some of the most brilliant engineering on the planet. So what is that blueprint? What is the secret architecture that makes these systems so incredibly intelligent?
Here's how we're going to tackle that question. We're going to build our understanding from the ground up, piece by piece. We'll start with the very core of AI, which is actually inspired by our own brains. Then, we'll see how adding depth to that core is what creates real intelligence. After that, we are going to talk about the single biggest breakthrough in AI history, the transformer. And finally, we'll see how all those pieces fit together.
So our journey begins right here, with the foundation of pretty much every modern AI system you can think of, something called the neural network.
So what in the world is a neural network? Well, at its most basic level, it's a computer system that's literally inspired by the structure of the human brain. It's designed to process information by passing signals through a whole web of interconnected nodes, which act a lot like the neurons in our own heads. And it's this structure that allows it to learn from data.
The way it learns is actually a pretty straightforward 4-step process. First, you have the inputs. That's just the information, the data that you feed into the system. That data then travels through layers of these mathematical units that we call neurons. Now, step 3, this is the really crucial part. As the network is training, it's constantly adjusting these tiny numerical values called weights that connect all the neurons. That adjustment, that fine-tuning of the weights, that is the learning process. And finally, based on all those learned weights, it produces an output, its answer.
And the analogy to our own brains here is it's perfect. Think about how you learn anything, like a new language. The first time you hear a new word, the connections in your brain are weak. But the more you hear it and use it, the stronger those neural connections become. AI learning is a lot like that. It's not thinking in the human sense. It's mathematically strengthening or weakening those connections, those weights, that lead to the right answer over and over and over again through millions of trials.
Okay, so a basic neural network is a really cool idea, right? But on its own, it's not nearly powerful enough to run something like ChatGPT. To get there, we need to add a really crucial ingredient, and that ingredient is depth.
And this was the big question that AI researchers wrestled with for decades. We have this cool brain-like structure, but how do we give it the horsepower for complex reasoning? How do we make it truly, deeply intelligent? And you know what? The answer turned out to be really simple in concept, but unbelievably powerful in practice. You just add more layers, lots and lots of layers. When a neural network has many, many layers stacked on top of each other, it becomes a deep neural network. And that right there is where the term deep learning comes from. It's not about philosophical depth, it's about architectural depth.
See, each layer in a deep network kind of specializes, and it creates this amazing hierarchy of understanding. Just imagine the AI is reading a sentence. The first, earliest layers might only recognize basic shapes, piecing them together to form letters. Then, the next layers up might group those letters into words and start identifying basic grammar. The deeper layers start to figure out the context, the nuance, the meaning behind the words. And finally, the very last layers assemble all of that understanding into a coherent, intelligent response. It's like a ladder of abstraction, climbing from simple little patterns all the way up to complex ideas.
Okay, so we've got our core component, the neural network. We have our method for making it intelligent, which is deep learning. But to get to the kind of AI we have today, one more piece was missing. And this piece wasn't just an improvement, oh no. It was a complete and total revolution. And this is the transformer.
I just want you to look at this number for a second. 2017. This is the year that everything, and I mean everything, changed in the world of AI. Before 2017, progress was pretty steady. After 2017, it went completely exponential. This year is the dividing line between the old era of AI and the modern era we're in now.
And it is absolutely no exaggeration to say that the introduction of the transformer architecture is the single most important event in modern AI history. Period. It unlocked capabilities that, frankly, researchers had only dreamed about before.
So what was the secret sauce? What made it so special? It was a brand new mechanism called self-attention. Now, before transformers, models had to read a sentence word by word in order. The problem was, they often forgot the beginning of the sentence by the time they reached the end. Self-attention changed all that. It allows the model to look at the entire sentence all at once and to weigh the importance of every single word in relation to every other word. This is how it understands tricky things like context, nuance, and even sarcasm, by seeing the whole picture instantly.
And the benefits of this were just staggering. With self-attention, the models achieved a much deeper understanding of language. They could be trained way faster. Their ability to remember things and maintain context over really long articles improved dramatically. And they became far more efficient at learning. You name the metric, it shot through the roof.
So the crucial takeaway from this whole section is this. Every single large language model you hear about today, whether it's GPT, Gemini, Claude, you name it, is built on the transformer architecture. Let me be perfectly clear. Without that breakthrough of self-attention back in 2017, our current AI world would simply not exist.
Okay, so we've looked at all the individual ingredients. Now, let's finally put them all together and look at the complete recipe for a modern AI model.
And this brings us to the full picture. It's like a 3-layer cake. You start with the fundamental concept, the core idea of a neural network, inspired by the brain. Then you make it powerful by adding dozens, even hundreds of layers, creating a deep learning system. And then you supercharge the whole thing with the transformer architecture, giving it that unprecedented ability to understand context. These 3 elements right here, they are the pillars upon which all of modern AI is built.
So there you have it. From a simple brain-like core to these deep layers of understanding, all of it revolutionized by the game-changing transformer. That is the blueprint of the AI that is changing our world today. And it really leaves us with a fascinating question, doesn't it? If the transformer changed everything in 2017, what will the next breakthrough be and when will it arrive? Thank you so much for joining me for this explainer. If you found it valuable, please remember to like.
Magic, but I promise you, it's not. We're going to demystify the whole thing by building an AI from the ground up, one concept at a time. And we'll be using the key ideas from Zahil Ahmad Mir's book to really see what makes these incredible systems tick.
So here's our game plan for building our AI today. First, we're going to install its core engine, the part that actually understands language. Then we need to fuel it up with knowledge about, well, everything. After that, we'll teach it some manners, how to be a helpful assistant. Then we'll put all the pieces together to assemble the final brain, and for the grand finale, we'll give it senses that go way beyond just words.
Okay, first things first. What is the secret sauce that lets an AI understand language? The entire revolution in modern AI, literally all of it, boils down to one incredibly powerful idea, something called self-attention. The best way to think about self-attention is to see it as the AI's ability to focus, right? When you read a sentence, your brain just automatically figures out which words are the most important and how they all connect. Self-attention gives AI that same superpower. It's the mechanism that lets it weigh the meaning of different words to really grasp the true context, just like we do. Let's take a super simple sentence like this one. For you and me, the meaning is totally obvious. But for a computer, figuring out the hidden relationships in these words is a huge challenge. Without self-attention, an AI would be completely lost here. It's got no clue if the lawyer thanked the judge or the other way around. It wouldn't know that the word him points directly back to the judge. This mechanism is the engine that lets the AI map out all these connections to build a real sense of meaning. And that's why modern AI can understand everything from a complicated legal document to the emails you send every day. But, you know, a powerful engine is pretty useless if you don't give it any fuel. So the AI has this amazing ability to understand, but now it needs knowledge to actually work with. And that brings us to the next step, powering up that engine through a process called pre-training. This is basically the AI's university education. I want you to imagine feeding an AI a massive chunk of the internet. All the books, all the articles, websites, research papers, you name it. During pre-training, the AI model reads and processes this gigantic library of human knowledge. And the goal isn't to memorize it, but to learn the patterns hidden inside it all. So what's really happening here is pretty mind-blowing. The AI isn't just making a giant list of facts, it's learning the fundamental rules of how our world works. Sure, it learns grammar, but it also picks up on common sense, like knowing that Paris is the capital of France, or that gravity makes things fall down. It's building a foundational model of reality, all from the text it's been fed. All right, so after all that pre-training, our AI is incredibly knowledgeable. It's like a genius who has read every book ever written. But it doesn't really know how to talk to people or how to be hopeful. It's just pure, raw intelligence. And that's where the next crucial step, fine-tuning, comes into play. Fine-tuning is all about how we shape that raw intelligence. This is where humans get involved to teach the AI how to behave. We guide it, we show it how to give helpful answers, how to follow instructions, and, this is really important, how to be safe and avoid generating harmful stuff. This is the process that turns that brilliant know-it-all into a genuinely useful assistant. So this really breaks it down. Pre-training is all about gaining knowledge, letting the AI learn by itself from a sea of data. The result is raw, unfiltered intelligence. Fine-tuning, on the other hand, is about gaining behavior. It's a process guided by people to create a helpful and useful partner that we can actually have a conversation with. Okay, so what happens when you put all of these pieces together? You take that self-attention engine, you fuel it with a universe of pre-trained knowledge, and then you shape its personality with fine-tuning. What you get is the modern AI brain, a large language model, or an LLM. This is the term you're hearing absolutely everywhere now, right? LLMs are the big players, systems like GPT-4, Claude, and Gemini that are really driving this AI revolution. They're called deep neural networks, which just means they have lots of layers to understand really complex patterns. And trust me, the large in their name is not an exaggeration. Their power comes from just sheer scale. Think of parameters as tiny little knobs inside the AI's brain that get adjusted during its training. The more knobs you have, the more nuanced its understanding can become. And they're built with what are called transformer layers, which is the architecture where that self-attention magic really happens. It's this combination of massive scale and brilliant design that gives them their incredible power. And because they're so powerful, the list of what they can do is just staggering. They're not just single task machines. They are true general-purpose tools. They can write a poem for you, analyze a dense financial report, translate languages on the fly, summarize a research paper, explain a tricky concept. They can even help you plan your next vacation. They are becoming these universal tools for thinking and creating. But the story doesn't end with just text. Up until now, these powerful AI brains could only understand the world through words on a page. The next great frontier is giving them senses, just like us. And this is being made possible by a concept called multimodality. Multimodality simply means the AI is no longer stuck with just text. It's learning to process and connect information from different modes or different types of data. It's not just a wordsmith anymore. It's becoming an observer of our digital world with the ability to see and to hear. So what this means is that now an AI can look at a photograph and tell you what's in it. It can listen to a podcast and transcribe it. It can watch a video and summarize what happened. And the really cool part is it can combine these things. It can read a document that has both text and charts, and it can understand how they relate to each other. This creates a much, much richer understanding of the world. And this just blows the doors open for how useful AI can be in a whole new set of fields. In medicine, an AI can now look at an X-ray and read the doctor's notes to help make a diagnosis. In education, it can watch a how-to video and then create a pop quiz about it. This is what brings AI out of the world of just text and into our complex, visual, and noisy world. What this all boils down to is that AI is starting to perceive the world in a way that is much, much closer to our own human experience. We don't just understand things by reading about them. We see them, we hear them, we experience them through all our senses at once. And now AI is starting to do the very same thing. And that leaves us with a final, really powerful question to think about. As AI develops these new senses, it's becoming more than just a smarter tool. It's becoming a fundamentally different kind of partner, one that can see our work, hear our ideas, and understand our world more deeply than ever before. So the question is, how will that reshape our partnership with it in our lives and our work? Thanks so much for joining me for this explainer. You have to start from scratch. It is so frustrating, right? Well, that exact problem is what this next evolution of AI is finally solving. Okay, so the first huge level up is giving AI a real persistent memory. And I'm not talking about a tiny little tweak here. This is a foundational change that completely rewrites the rules of what's possible when we interact with these things. This really changes the whole dynamic, doesn't it? We're shifting away from this old model of AI as a tool, one that you constantly have to remind and re-explain things to, and we're moving towards AI as a partner, one that actually remembers the context of your conversations and builds on that shared history over time. So how on earth does this actually work? Well, the key piece of tech is called a long context window. And honestly, the best way to think about it is like giving the AI a massive upgrade to its working memory. It allows it to hold and process just an incredible amount of information all at the same time. And the scale of this is, well, it's kind of staggering. We're not just talking about it remembering the last sentence you typed. We're talking about the ability to read an entire book, or analyze hundreds of pages of dense research, or go through a complete legal case file from start to finish, all in one shot. And here's the part that is just a total game changer. It holds all of this information, all of this context, inside a single continuous conversation. The whole book, that entire massive contract, it's all right there in its working memory. The AI never, ever loses the thread. So once you have that kind of persistent memory, it becomes the foundation for much, much higher level thinking. It unlocks the ability to do deeper analysis and sustained reasoning. Suddenly, the AI can actually do long-term planning and execute really complex, multi-step tasks, all because it finally remembers what it is you're trying to accomplish together. But look, remembering is only half the battle, right? Once an AI has this super reliable memory, what's the next logical step? Well, it's got to be able to act on that knowledge. Memory is the foundation for sure, but action, that's where this technology really becomes transformative. Because, having all that information is great, but the real magic happens when the AI can take that memory and use it to actively go out and get things done for you in the digital world. And the technology that makes this happen is called agent architecture. You can pretty much think of it as the system that gives the AI hands and feet to move around the digital world. It's the framework that lets it go beyond just understanding information to actually performing tasks on your behalf. So what does this action actually look like? Well, an AI agent can literally browse websites, click on buttons, and fill out forms, just like you or I would. It can even write and run its own code to solve a problem, pull specific data out of a document, and then use that data to create something totally new. It can complete an entire workflow from start to finish all by itself. And this is the core promise of this whole new era. We're shifting from an AI that you have to work on, like you would a simple tool, to an AI that works with you as a real collaborator and for you as a seriously capable assistant. Okay, so we've got memory and we've got action. But they don't just exist in a vacuum. They are two critical parts of a much bigger, much more sophisticated system, what you could call the new engine that's powering modern AI. And this engine, it's got several key parts. Now, the foundation is built on stuff that's been around for a bit, like transformer architectures, which are great at understanding context. But the new stuff, the exciting stuff, are these layers built right on top, those advanced memory systems we just talked about, and the agent frameworks that let it take action. Then you combine all that with the new ability to see and hear, and wow, you get something else entirely. So what happens when you get this engine firing on all cylinders? Well, you get an AI that moves way beyond just understanding and learning. It can now actually reason and plan. It can generate brand new ideas and collaborate with you in real time. It becomes a true partner that helps you get work done and discover things you never would have found on your own. So when you pull all of these architectural upgrades together, what you're left with is something that feels, well, less like a machine and a lot more like your smartest partner, one that's ready to jump in and help you tackle some of the most complex challenges you face. It's really a huge leap forward. We've gone from an AI that could just understand text to one that can also remember everything. And now to one that can finally act on all that knowledge. Understanding, memory, and action. Those are the three pillars that define this whole new generation of AI. Which, of course, leaves us with the next giant question. Now that we understand this new architecture that powers its intelligence, we know how it remembers and how it acts. So how do we need to change the way we talk to it to unlock its full potential? That right there is the key to mastering